Welcome to The Explainer. Today we're diving straight into one of history's absolute most fascinating unsolved puzzles. Back in 1897, a world-famous composer sent a really strange coded message to a friend. And for over a century, the greatest code breakers out there have tried and entirely failed to read it. But today? Well, today, we finally have a highly testable, data-driven solution that might actually crack this case wide open.
Here is our roadmap for today. 1. The unsolved Dorabella Cipher. 2. The musical cadence hypothesis. 3. Decoding the hidden message. 4. A falsifiable test protocol. 5. Parameters for falsification. And finally, 6. The most plausible solution.
Section 1. The unsolved Dorabella Cipher.
Now, what's really interesting here is this collection of 87 squiggly symbols. Back in July of 1897, the brilliant composer Edward Elgar sent this exact note to his friend Dora Penny. As you'll notice, there are no standard alphabet letters at all, just these strange little curved shapes. For literally decades, cryptographers and history buffs have stared at these exact 3 lines, desperately trying to figure out what Elgar was trying to tell her.
So why has it remained such a massive mystery for so long? Mostly because almost everyone starts with the exact same failed assumption, that one symbol equals one letter of the alphabet. But the reality is, this specific set of symbols is simply way too constrained for that. The repeating curved forms act a lot less like random letters and much more like highly controlled repetitive patterns. If you go into this expecting normal English words, you're gonna hit a wall every single time.
Section 2. The musical cadence hypothesis.
What if the composer wasn't writing standard letters at all? What if he was actually writing music? To really understand this, we have to look at the work of researcher, inventor, and author Kevin L. Brown. Brown introduced a fascinating research model called triune harmonic dynamics, or THD. He proposes a groundbreaking, completely testable idea. The Dorabella Cipher is actually a musical cadence encoding system. Remember, Elgar was a composer. These symbols don't map to text. They represent compressed musical phrases, capturing things like motion, rhythm, and stress. So the crucial point is how these visual shapes actually function as pure data. It basically breaks down into 4 distinct features. First, which way the symbol points tells us the musical pitch direction. Second, whether it has 1, 2, or 3 curves represents the rhythm or the stress. Third, the 3 groove symbols act like structural boundaries, chopping the whole message into smaller chunks. And fourth, the physical line position tells us its role in the phrase. It's absolutely not an alphabet. It's a super compact musical note system.
Section 3. Decoding the hidden message.
If we use this musical method to compress those 87 symbols down, what does it actually say? Well, it translates to this. Do you hear the tune? Answer me, Dora. E. It is a stunningly simple and just a perfect fit. I mean, it reads exactly like a composer's private musical joke to a friend. It's short, it's intimate, and it's deeply musical. It doesn't read like a stiff, formal military code, because it never was one.
And notice how this builds perfectly onto the physical structure of the original note. The cipher was written out in 3 distinct lines. Under this hypothesis, line 1 is the musical prompt, do you hear the tune? Line 2 is the direct request, answer me, Dora. And line 3 serves as the identity closer, ending with EE for Edward Elgar. The 3 physical lines map absolutely flawlessly to these 3 structural parts of the message.
Section 4. A falsifiable test protocol.
Okay, let's dive into this because we can't just take a good guess and call it a day. A really strong scientific theory must be testable and repeatable by anyone. Here are the exact steps a researcher or even an AI system would take to independently test this without any human bias. First, you transcribe every symbol based on its direction and curves. Second, mark all the 3 curve symbols. Third, segment the cipher at those specific markers. Fourth, calculate the direction and length for each chunk. And finally, compare the lines and check if that last line actually acts like a signature. This is a fully repeatable mathematical process.
Section 5. Parameters for falsification.
And this brilliantly illustrates what makes it real science. For any theory to be valid, we need to know exactly what parameters would actually prove it wrong. Here are the strict rules for that. If the 3 curve symbols don't actually occur at meaningful boundary points, well, the model weakens. If grouping the segments together doesn't improve coherence over just random chunking, the hypothesis fails. If the final line shows no signature behavior, or if the symbols don't produce a distinct musical shape, it's just wrong. And finally, If the real message translates to some massive, long sentence, this model fails because the structure is strictly built for a very short note. It relies entirely on hard data, not guessing.
Section 6. The most plausible solution.
So why does this specific data-driven approach work so much better than any other attempt in history? Because it effortlessly satisfies 4 independent constraints. First, the musical constraint. Do you hear the tune? Perfectly matches the musical look of the cipher itself. Second, the social constraint. Answer me, Dora, totally fits their personal relationship context. Third, the signature constraint. EE gives us a completely natural Elgar sign-off. And fourth, the structural constraint. The 3 physical lines of Elgar's note map directly to the prompt, the request, and the signature. It explains the cipher's form, the author, and its function, all at once.
Which leaves us with a pretty provocative thought. The ultimate test of any good data is replication. By feeding this exact same method into modern AI, researchers can run this test without a single ounce of human bias. If an AI recovers the exact same phrase structure, this 1897 mystery might finally have a proven, undeniable solution. Thank you so much for joining me on this explainer today, and remember to always keep questioning the data.